Hey, Japanese Life Math and History, and we are going to learn about colinear and non-colinear and see what they mean. So, we understand that there's something that's acceptable and something that isn't. So when you think of linear, you probably think of a straight line. Well, yeah, this is what this lesson is all about. Straight lines, like this. So when you think of colinear, and in geometry, we like to use like points and lines like these. Well, colinear has both of these things included. Colinear means that there are lines. Well, there are points that can make a line. So if colinear means that points that can make a line, what is non-colinear? Well, to understand this more, here's an example of what colinear means. So the coins making a straight line can be an example. But what happens when something is not colinear? Well, it's kind of self-explanatory. If it's not in a line, instead, the dots are going to be spread out like this. A lot of the times, your geometry teacher will show dots that can make up a triangle. So now we know the difference between the two. We can say the points A, B, C can be colinear. However, we can say the points J, K, L cannot be colinear. And since J, K, L has 3 dots and it always is in the form of a triangle, that is what we're going to be learning next. Now, we are going to learn about triangles that have inequality in them. So triangle inequality is a special theorem that uses colinear and nonlinear examples. So, there are 2 things that we can look at with a triangle. The first one is, if you have 3 points on a triangle and you make lines of them, the thing is that when you try to say that they're colinear, well, you can't, because not all the points are on the same line. In this example, these would be non-colinear lines, because not all of them are in the same line, just like these are on the same line. And sometimes triangles would appear like this. The reason why we're showing you that triangle is because it will lead to our second theorem. So our second theorem is also about triangles with inequalities. So this one is about right angles and right triangles. So right triangles have 90-degree angles, and it states that the sum of the length of 2 sides, any 2 sides of a triangle, is a lot longer in distance than the length of the third part of the triangle. So if you remember in the previous videos long ago, we were learning about Pythagorean theorem, like a squared plus b squared equals c squared. So we're going to put 3 here and 4 here. We're going to explain why the sum of 2 lengths of a triangle is much larger than the third. So we're going to do the Pythagorean theorem to find out what this one right here is, the hypotenuse. So 3 squared plus 4 squared equals whatever squared. So 3 times 3 is 9, plus 4 times 4 is 16, which equals 25. 25 square root, because we're trying to find what the question mark is, we get 5. Therefore, 5 is the length of the hypotenuse. So if you add 3 plus 4, it's bigger than 5. So 3 plus 4 is greater than 5. If you do 5 plus 4, it's greater than 3. And if you do 5 plus 3, this plus this, it's going to be greater than 4. That can explain why the two sides of any triangle that you add up is larger than the third. We're going to show you a visual perspective of why this happens. Okay, so here's what I did. I tried arranging the Vexrobotics parts to make it look like a right triangle. So let's see. We're going to have this and this, two of the legs added together. Then we have this hypotenuse right here. See, it's a lot longer with 2 than 1 hypotenuse. Let's reset it. Now, I'm going to have the hypotenuse and one of the legs. And it's a lot longer than this one. Back to reset. The last one, we're going to get the hypotenuse again with this leg right here, which is a lot bigger than the third one right here. Back to resetting. So, visually, we have proved that when you grab two sides of the right triangle, any two sides, add them together, and it's going to be much, much bigger than the third. This is helpful with triangle inequality, and it's also helpful for more complex problems that are soon to come. For example, here's the complex example. So here is a shape that was given to us by one of our math teachers. We can say that A, B, and C as points can be colinear. We can also say that A, E, and B are non-collinear. So this is collinear, this is not collinear. So that is how we can explain triangle inequalities and also explain collinear and non-collinear in a fun and cool way. Thank you for watching Top Opinion Math Industry. Like and subscribe.